Here we go. Equilateral and isosceles triangles. So an isosceles triangle. An isosceles triangle has at least two congruent sides. So if we make a line of reflection and cut it right down there, and this flops over, what do we know about C and A? If we flop this onto this, they're congruent. So what happens in isosceles triangles is if you have two sides congruent, then their opposite angles will be congruent. Okay? So if side BC and AB are congruent, then side angle C is congruent to angle A. If you have two congruent angles, then their opposite sides are congruent. Then AB would be congruent to BC. So if you have congruent angles, then the opposite sides are congruent. If you have congruent sides, then the opposite angles are congruent. So, how many degrees are in a triangle? 180. You need to know that today. 180. So if we use 50 of it right here, what are left for E and F? No. So if we make E and F x, x plus 50 equals 180, right? If we subtract the 50, 2x equals 130. That's how much is left for those two angles. And if we divide by 2, each angle is 65 degrees. Both E and F are 65 degrees. Okay? If angle A is 28 degrees, angle A is 28 degrees, how big are angles B and C? Well, we make them each x. What do we write down for an equation? Or 2x plus 28 equals 180, which is fine. If we subtract 28, two x equals 152, divide by 2, 76 degrees. That's what's each of those missing angles. Okay, it says, what are the lengths of all three sides of the triangle? Are all three sides congruent? No, not all three. So which sides are congruent? Is it the x plus 20 and 6x minus 12? No. Is it the x plus 20 and 8x over 3? Yes. So those two are congruent because the opposite sides of the congruent angles are congruent. So you got to know which sides are congruent, Mia. So x plus 20 equals 8x over 3. Now, how many of you in here like fractions? That's what I thought. None of you. So we want to get rid of fractions whenever possible. So how can we get rid of this fraction? Multiply both sides by 3. So multiply by the denominator. If we multiply both sides by 3, the 3's cancel here, and we get 3x plus 60 equals 8x. Now, how do we get x alone? Subtract 3x. You always move the variables first, not the numbers. So 60 equals 5x, divide by 5, x equals 12. So if x equals 12, how long is PR? 32. How long is QR?
32. Oh, wait, no, just kidding. Wait, no, it is 32. No.
Why wouldn't it be 32, Ella?
Oh, wait, QR. I thought it was PQ. Yeah, 32.
Because if this is 32, this better be 32, or we went up the creek without a paddle.
That's so funny.
All right, because what's 8 times 12? 96. Divided by 3 is 32. All right, what is PQ? Now that's a little different. 6 times 12 is 72 minus 12, 60. So PQ is a little longer. That's 60. Okay? All right. If this is 132 and this is 24, what's left for angle A? If this is 132 and this is 24, what's left for angle A? 24. Because this adds up, these two add up to 156. 180 minus 156 is 24. So thus, it's an isosceles triangle where this side and this side are congruent. So 2x plus 15 is equal to 4x minus 5. What do we move first? Subtract 2x. So 15 is equal to 2x minus 5. Then what do we do? Add 5. So 20 equals 2x. Divide by 2. X equals 10. Once we get x equals 10, life is easy. What's 40 plus 12? So AB is 52. What's 40 minus 5? 35. What's 20 plus 15? 35. Okay? You find all three sides. So if you add them up, they add up to 122, and that is the perimeter because it asks, what is the perimeter? Make sure you look and see what it's asking for. All right. So what this is saying is if we bisect the top angle of an isosceles triangle, it makes a perpendicular bisector of this side. It's perpendicular and it hits it, so it divides it at its midpoint. So if you bisect the top angle of an isosceles triangle, it makes a perpendicular bisector. All right, knowing that, let's say you're a house mover and you're moving this house, okay? And along the way, there's a bridge clearance of 17 feet. Can you make it under the bridge, or are you going to rip off the top of that house if you try to go under that bridge? You're going to probably rip it off according to Ella. Let's see. Okay. What we got going here is we have an isosceles triangle at the top because it's 16 and 16. The base of the, when you see a house go down the road, sometimes they have it split in half of two houses. Haven't you ever seen that going down the road where they have a house where it's like wrapped in plastic on one side, and then a little ways behind there they have the other half going down the road? A semi is pulling it. Well, they screw it together. They don't glue it together. They screw it together. Yeah.
Survive like hurricanes and stuff. They do.
They do. Yeah. So these are like mobile homes. Hey, if you ever been to a mobile home park, there's these double wides. This is a double wide, okay, that they can go down the road with, okay? So this is 16. We need to figure out the height of the triangle. Now the base is 28, which means it's 14 and 14 here, okay? Now, since we have a perpendicular bisector going on, okay? Since we have a perpendicular bisector going on, it made two right triangles. Now, in a right triangle, if you know two sides of the right triangle, how do you find the third side? This Greek guy came up with a thing. Pythagorean theorem. What is a Pythagorean theorem? Well, a squared plus b squared equals c squared, where c is always the hypotenuse. What's the hypotenuse? The longest side, the side opposite the right angle. In this case, it's 16. So, h squared, the height, that's this side, plus 14 squared equals 16 squared. So h squared plus 196 equals 256. So if we subtract 196, we get h squared equals 60. Well, if we take the square root, you need a calculator, somebody. What is the square root of 60? About 7.7. Now, if this is 7.7 right here, and this is 10 right here, what's the height of the house? 17.7 feet. It's going to hit that bridge. It's going to rip the top off, so the driver needs to find a different route. Okay? All right, equilateral triangles. Every equilateral triangle is equiangular. Every equiangular triangle is equilateral. So if all the sides are congruent, that makes all the angles congruent. If there's 180 degrees in a triangle and you have 3 angles, what's the measure of each angle? 60 degrees. Every equilateral triangle, the angles will all be 60 degrees. If you have a triangle with all 60-degree angles, all the sides will be congruent. All right. So in this, we want to figure out what is the measure of angle BAD, this angle here. Well, what do we know about ACB, each angle in ACB? They're all equal to 60. Now, if CBD is 130, this angle right here is 130. What's this angle right here? What's this angle here? If this is 130, what's ABD? How about 70? 60 and 70 make 130. CBD is 130. If this is already 60, this has to be 70 to make 130. All right. So we have an isosceles triangle, so this angle and this angle are congruent. If we use up 70 for this, how much is left for these two angles? 110. So angle A and angle D add up to 110. If we divide them by 2, they are each. So BAD is 55 degrees. Had to do some work for that one. All right, so an isosceles triangle. 2 congruent sides, the opposite angles are congruent. If we have 2 congruent angles, the opposite sides are congruent. If you bisect the vertex angle, this is called a vertex angle at the top, the vertex angle, the non-congruent angle is a vertex angle, the other 2 angles are called base angles. The 2 congruent sides are called legs, the non-congruent side is called the base. But if you bisect the vertex angle, it makes a perpendicular bisector. Okay? When you bisect the vertex angle of an isosceles triangle, it makes a perpendicular bisector, splitting these in half. An equilateral triangle is equiangular. An equiangular triangle is equilateral. Let me put out your next assignment.
My wrist like my nose.